Hello, this is the luckiest maths teacher in the world. Thank you so much for tuning into this video in which we will look at exponential growth and decay. So an example of exponential growth is compound interest, and I want to explain what exponential growth is using the example of compound interest. See, in the previous lesson when we looked at exponential graphs, I mentioned that exponential growth means that the quantity is increasing at an increasing rate. So if you invest $10,000 and receive 10% per annum compounded annually, how much money would you have? Well, at the end of the first year, you just take 10,000 and you add 10% of that, you now have $11,000. Now, what happens with compound interest, at the end of the second year, you earn 10% of this. So this time you won't earn $1,000, you'll actually earn $1,100. So it will go up to $12,100. Then, year 3, you'll earn 10% of this. You will earn 1,210. So you'll get 13310. And it keeps going in this pattern. As we can see, the first year increased by 1,000, the second year increased by 1,100, the next year increased by 1,210, and so on. This is what I mean by increasing at an increasing rate. Not only is the amount you have increasing, but the amount by which it's going up also increases. Of course, this would get very tedious. What if we wanted to know how much you'd have after 20 years? Well, we don't want to follow this process. There's an easy way to do it. See, all we're doing is taking 10,000. Now, increasing by 10% is the same as finding 110% of the quantity. So you're taking 10,000, you're timesing by 1, which is 100%, and then you're adding 10%, which is a tenth. So you're doing that 20 times. And you can put that on your calculator. After 20 years, you'd have about $67,275. All right, let's look at some more examples. So this is the formula we used in the previous example that we use for exponential growth or decay. So this plus or minus means you use plus if it's growth, if it's going up, and you use a minus if it's decaying, if it's going down. So in this example, population of a town is decreasing by 5% each year. If the population is currently 36,000, calculate the population in 20 years' time. So we will just take A as the amount that we have. P is what you start with. So in this case, 36,000. So we're timesing it by 1 minus because it's decreasing. This is exponential decay. R is the percent over 100 and to the power of the number of decreases, in this case 20. And putting that in our calculator to the nearest whole number, we have about 12,905. So with exponential decay, it decreases at a decreasing rate. So 5% of 36,000 is 1,800. So the population of this town would decrease by 1,800 in the first year. It'd decrease by a little less in the second year, a little less still in the third year, and so on. So 5% times 20 is 100%, but you can see that the population didn't decrease to 0. It didn't decrease by 100% because the amount by which it's decreasing goes down each year. That's why there's still 12,905 people. Now I need to make a note about when you're doing compound interest. So let's say I invest $20,000 at 6% per annum compounded monthly. How much will I have in 15 years' time? So we're still using the same formula that we used for compound interest on the previous slide. But when it is compounded not annually, you need to change it so that R, this number here, and N are essentially in the same units. So for this, we still have P is 20,000. That part hasn't changed. But what we need to do is we need to change R and N into months. So 6% per annum, 6 divided by 12 is actually the same as 0.5% per month. So in this formula, I'm going to substitute R for 0.5. And n will be the number of months. So in 15 years, there are 15 times 12, or 180 months. And so to the nearest dollar, we get about 49,082. So the more frequent the compounds, the more money you have. If it was 6% per annum, you'd earn slightly more money if it was compounded monthly than if it was compounded annually. You'd earn more money if it was compounded daily than compounded monthly. Now, all the compounded means is just that it's recalculated. So they recalculate how much money you have in the account and calculate your interest at the end of each month, rather than the end of each year. So the more frequent the compound, the more money that you have. All right, let's now look at solving for R or P. So my car has been losing 10% of its value each year. If it's currently worth 15,000, what was its value 10 years ago? So we're still using the same formula, A equals P 1 minus R over 100 to the power of N. So in this case, A is 15,000. Now P we don't know. We don't know the value that this was when it started losing its value. So in brackets, we go 1 minus because it is losing value. This is exponential decay. So R is 10, so R over 100 to the power of N, which is also 10. So this is a really easy equation to solve. This here is just a number. Not going to be a very nice number, but a number nonetheless. So we can get P by itself by simply dividing each side. So P will simply be 15,000 divided by that number 1 minus 10 over 100 to the power of 10. And putting that on our calculator again to the nearest dollar, we get about 43,020. All right, what rate of interest is required to double my investment in 10 years if interest is compounded annually? So let's again look at our formula, A equals P 1 plus R over 100 to the power of N. In this case, we are being asked to find R because we're looking for the rate of interest. Now we know here that N is 10, so let's just substitute for 10. We don't need to change N here because it's compounded annually. So that's good. So what about A and P? Well, it turns out it actually doesn't matter how much you start with. It will actually be the same rate of interest required if you want it to double, whether the initial amount was $1 or $1 million. And the reason for that is we want A to be 2P. That is what it means if the investment doubles. It means that the amount you have now is double what you started with. And that's really helpful because we can cross out the p's, divide each side by p, and we have 2 equals 1 plus r over 100 to the power of 10. All right, how are we going to solve that? Well, we need to undo what's been done to r. So here r was divided 100, added to 1, and then raised to the power of 10. Because this was the last thing done to r, it's the first thing we undo. So what I'm going to do is actually take the 10th root of both sides. So that'll leave me 1 plus r over 100. All right, now I want to get r by itself. Next thing I need to do is get rid of the 1 by subtracting. So I get 10th root of 2 minus 1 equals r over 100. So now I'm just going to multiply each side by 100 because then I'll get r by itself. And I can put this straight into my calculator. So putting that in our calculator, we get that R is about 7.18%. All right, let's look at one harder question now. Suppose the price of milk increases by the same percentage each year. Milk will be worth $5 per litre in 10 years, $8 per litre in 20. Calculate its current value and percentage increase. So hopefully you're thinking, because we're finding two quantities at once, simultaneous equations. So because it's increasing by the same percentage each year, that's exponential growth. So let's write our formula here. Now, the first bit of information says it's worth $5 per litre in 10 years. That means when n equals 10, a equals 5. So let's substitute in those values to get one of the equations. And as you can probably predict, we can substitute a for 8 when n is equal to 20. So here we have two equations. Now, this is not a pair of simultaneous equations that you're used to, but we're going to use the same method we've used of elimination. Problem is, each of these equations has two unknowns and so infinitely many solutions. But what we're going to do is combine the equations and get rid of one of the variables. Then we have one equation with one variable. Now, I can actually get rid of the p's here by dividing one equation by the other. So what I'm going to do, I'm going to go 8 divided by 5 is 1.6. P divided by p, well, that's just 1. They just cancel out. Now, something to the power of 20 divides something to the power of 10 just equals something to the power of 10. When we divide bases, we subtract the powers. See, now we have an equation that looks very similar to the one that we solved on the previous slide. So what we're going to do is take the 10th root of both sides, subtract 1, and multiply by 100. So putting that on our calculator, we get that R is about 4.81%. So what is the value of P? Well, we just substitute it into either equation. I'll just substitute it into there. So P is just going to be 5 divided by this number here. So just be careful. This number here, we want to use the answer function in our calculator. We don't want to round it. And when we put 5 divided by this on our calculator, we should get $3.125. $3.12.5. All right, thank you so much for tuning into this video. This has been the luckiest maths teacher in the world. Have a great day.